Okay, guys, this is Dr. Wesley. Let's start with section 5.1. All right, when we're looking at joint probability distributions. I guess I can't write too far up. Probability distribution. You'll have to excuse my handwriting. It's not going to get any better, I think. So last time we talked about looking at joint probability distributions of discrete random variables. There were essentially two properties that we wanted to, well, three properties that we wanted to focus on. First, that f of xy has to be greater than or equal to 0 for all xy. Two, the double sum over all x and y of our function f of xy has to be equal to 1. And three, we define our probability that our random variable x is equal to little x and y is equal to little y is given by a function f of xy. Okay. There was another kind of a sub property that if we have some region A and we want to know if our point xy is in A, what's the probability of point xy is in A? Where we're going to sum over all of the function values f where x and y are in A. Okay. And we'll look at an example of that in just a little bit. We did an example of a table last time we met in class. And what we're going to do is, because I don't have access to the PowerPoints that I can just plug directly into this video, you guys just follow along with the PowerPoint of chapter 5. And that PowerPoint for chapter 5 is posted on Canvas. And so we're going to be looking at example number 3.51. And I hope you guys are following along. 3.51. And it's a card example. It's a card example. And it says this: 3 cards are drawn without replacement from the 12 face cards, Jack, Queen, and King. So there are 4 Jacks, 4 Queens, and 4 Kings of an ordinary deck of 52 playing cards. Let X be the number of kings and Y is the number of jacks. Okay, Y is the number of jacks. And so what we want to look at is we want to find the probability that X is equal to 0, Y is equal to 0, probability X is equal to 1, Y is equal to 1, probability X is equal to 4, and Y is equal to 2. Okay, now notice that we're drawing 3 cards from 12, and we're looking at the number of a particular kings and number of jacks. And this is very similar to the hypergeometric problems that we did before. And this is a type of hypergeometric distribution problem, right? Where we're pulling a smaller sample from a bigger sample, right? And we want to know how many of a particular type that we have. What's the probability of that type occurring? So if we look at A, probability X is equal to 0, Y is equal to 0. Okay. Now, how can this occur? Well, how can we get 0 kings and 0 jacks? Well, we choose 0 jacks from 4. We choose 0 kings from 4. 0 kings from 4 and 0 jacks from 4. But then that means that we must choose the 3 cards from the queens. So from the 4 queens, we choose 3. Divide that by the total number of ways we can choose any of the 12 cards. Any 3 of the 12 cards, which is 12, choose 3. And the probability of that occurring is given by 1 over 55. B, what's the probability that x is equal to 1 and y equal 1? Well, that looks very similar to that. Probability x is equal to 1, y equal 1. That means we choose 1 king, 1 jack, and that must mean the remaining card has to come from the queens divided by the total number of ways we can do that. And I have 16 over 55. That's my answer. C, what's the probability of choosing 4 kings and 2 jacks? Well, the answer to that is 0, right? Because we're only choosing 3 cards total. So there's no way I can choose 4 kings and 2 jacks where I'm only choosing 3 cards total. This is 6 cards that I want to choose altogether. That's not going to happen. So probability of that is 0. So actually I said A, B, and C, but this is not A, B, and C. This is actually from the same problem. I have an eraser here, I think. Erase that. This is all A. Okay. And then so what B says, it said, what's the probability that x plus y is equal to 3? I'm going to do a simpler problem just to save a little bit of space. Probability that x times y is equal to 2. Well, so I want to look at all possibilities where x times y is equal to 2. Well, that's equal to the probability that x is equal to 2, y is equal to 1, plus the probability that x is equal to 1, y is equal to 2. Right? Those are the 2 ways that x times y is equal to 2. So x times y equal to 2 is our region A. Okay. And the ways that can occur, these are the 2 possibilities: x equal 2, y equal 1, x equal 1, y equal 2. And we can calculate the probabilities of those just like we did before. The first one would be 4 choose 2, 4 choose 1, 4 choose. So if I get 2 from the kings, 1 from the jack, that means I have 0 that I choose from the queens. 4 choose 3 plus, and then I can do it for the other one. So 4 choose 1, 4 choose 2. And so that means 0 for the queens. And if I calculate that, if I did that correctly, I get 12 over 55. I'm going to box this answer. I'm going to box my other answers too. That makes me feel good. Okay. So these are my answers for A and B. Now, if you look at this, each one of these examples, right, you notice that I thought there was a hand here. I don't have a hand. That's unfortunate. But you notice that if you look at these, in each one of these examples, there's a certain pattern that we have for all of these examples that we have here. The first one is that if you look at the part A, we have 4, 4, 4 always at the very top, and then you have 0, 0, 3, right? The zeros occur. If you look at this one, I'll change colors real quick. Right? These zeros occur here, and we have these zeros here as well, right? And then 3 is the remaining that we have left. Here we have these 1s occur here, the 1s occur here, okay? And then this 1 that we have here is what remains from the cards that we need to choose. And also what always is consistent, and we have 12 choose 3 at the very bottom. Okay, so that gives me an idea of what the pattern has to be for this particular thing. So if I go to the next one, okay, I'm gonna click on it. You go to the next one. I'm trying to get to the next layer. I thought I knew how to do it. Trying to use technology right when you're working on it is not the most effective thing, it seems sometimes. Huh. Okay. Well, let me stop the video and see if I can figure out how to switch this over to the next one. I just need to click on it. Okay.